Hi everyone, I'm Jody. Today I'm gonna present my capstone project. Following my last semester's research titled Beware, Virtual Reality is Manipulating Your Behavior When People Are Around, I'm quite interested in the concept of co-presence, specifically in the context of virtual environment mediated by screen-based web space. Therefore, as a continuation, my capstone project this semester intends to create a mixed interactive experience within both projected virtual space and physical space that speaks to the influence of co-presence on human behaviors. And I'll separate my presentation into three parts: virtual space construction, user interaction design with motion capture, and physical space installation with projection. First of all, the virtual space construction. As is introduced in Capstone 1, because I also took Professor Moon's webpage to web space course last semester, I was significantly inspired and developed a prototype synchronously as I developed my Capstone 1 research. So I constructed the basics of virtual world using Three.js, which also allows multi-user experience with the help of Socket.io. What makes this unique is that the embodiment of the user is the light with a random color through a first-person perspective, which means users would only see the views in front of a light through a screen, while he or she would not see themselves as a light, sphere, or any other shape. And the interaction is the basic keyboard navigation of moving and rotation. From first round of user test and interview, the feedback mostly lies in the indication of others in this virtual space, as some users found it hard to identify or regard it as a single experience. Therefore, as a starting point, I developed the virtual world in two directions: the visuals and embodiment. In terms of the visuals, because the original version contains geometric structures that are randomly generated, some users felt unintentionally distracted by the complication of structures. Therefore, after communicating with Professor Moon, I decided to experiment with simplified word structures, taking out the floating, irregular compositions. Instead, I made all cubes following a grid map with random height within certain range. Through such experiments, navigation became more important in this world, which provides more potential for later interaction design. Besides, through brainstorming with Professor Moon, I developed 4 ideation plans to enrich the embodiment. Among them, I eventually determined to add sound effects because the entire atmosphere was inspired by the abyss or the dark ocean, and the embodiment in such environment very much reminds Professor Wu of the creatures like humpback whales, which is a creature in nature that highly values community and often gives insights to humans. And this is the sound list that I downloaded and tested from online audio sources. With the help of the sound, users would better identify others, especially since it provides the possibility of identifying the distance through volumes. Say they would hear louder audio if they get closer, and with the help of the headsets, it would even add to the immersion of experience, while serving the purpose of co-presence very well. So following such idea, I started to implement through programming. Thanks to Socket.io, the data of different users from different parts joining the same space could be stored in an array. And therefore, by reading the data simultaneously, I obtained the exact XYZ position of each user following the access in this 3D space. With these values, I could calculate the distance between each two closest users, as you can see in the screenshot, and I print it out for now for examining the instant update of this value. Then, with this distance, I managed to update the volume of audio using map function. I set up a threshold of 100 in this 200 multiplied by 200 space, meaning that whenever one user is within a distance of 100 from another, they would gradually hear the sound. And similarly, the light frequency would also change. The more frequently it shines, the closer it would become to another light. And specifically in terms of the map function, through the analysis and comparison between linear and exponential mapping, I implemented the latter one because it leads to greater changes in volumes when the distance just touches upon the threshold of 100. This would serve as a stronger indication compared to linear changes. And the square feet would save more power to run other codes compared to higher exponents while achieving similar effects. And this is the demo video. You can check the distance value with the volume updates if you listen carefully. here's the distance value, and when it comes closer, the volume would increase, and then if you go further, it will just decrease the value, decrease the volume. And then for the interaction part, considering the format of projection installation, motion capture through a webcam could be the most appropriate in general because it could add to the immersion of this experience. And other possibilities such as navigating through a controller would easily distract the users and make it more like a gaming experience according to my previous case studies. And it is definitely not what I want. Technically speaking, I first experimented with the feature extractor plus KN classifier as one of the machine learning models from ML5. According to my sketch, I pre-trained 5 labels to KN classifier, each representing a direction with a default status of moving forward, and this is how it goes with a laptop. As you can see, basically the navigation is dependent on the head directions. And because it would be a space installation, I also set up the projection and tested with a webcam. And this is the video demonstration. So as you can see, the left and right navigation works kind of well, but in this video, later in this video, the up and down doesn't go that smooth. So to further improve this, I turned to fellows for comments and suggestions, and Sunny, as is demonstrated in this video, she suggested that the models like PostNet usually work better from her experience. So my next step in interaction development would be testing models like PostNet instead of feature extractor. And instead of classifying different body gestures, I would design to capture the angle of eye positions in order to identify directions. And this image demonstrates the setup of my testing. I listed equipment here and sketched a projection setup for each user. Considering the length of cables and positions of users and projectors, I would expect to hang the projector from top so that it wouldn't be blocked by the users. Cables and powers would all be connected to a laptop, which hopefully could be placed inside a physical white cube because it accords well with the geometric structures of word visuals. So this is my basic setup plan for projection for one user, and I would further accommodate the details based on the exact location of our final exhibition after it is assigned. And another focus of my second half semester would be the experience design of this installation. Inspired by the conversation with Samantha, another fellow, I would like to emphasize the juxtaposition of spatial co-presence. The co-presence of virtual space is already implemented through programming and motion capture, and as this installation already provides a physical 3D space, there exists great potential of manipulating physical co-presence with virtual co-presence, such as having 2 participants experience the virtual world with noticing each other at first, and then as they further experience, they would physically realize each other, thus perhaps triggering a strong sense of co-presence. And these are the 3 simple iterations of implementation plans, and I will dedicate more to such experience design later on. And here I made a general flowchart of my Capstone progress, starting with last semester's research, virtual world construction, interaction design, into the final space installation. We're now already halfway through, and for the rest of the time, my main focus would be 3 later parts. One is to finalize all visual designs of the virtual world, because Different colors and saturations would all have different effects through projection. So my final tunes would largely rely on projection testing. And second is to set up the installation, which includes device preparation and purchasing or say renting physical materials. And last one is to finalize the experience design. Following what I just introduced, with a more developed experience, I expect to capture the intention of users looking for others. Technically speaking, such intention could be captured by the frequency of users changing their directions toward others, and then I could update it to the feature of embodiment or other spatial changes. And this is my Gantt chart with full details of conducting this project. I'll end my presentation with special thanks to Professor Moon, Professor Wu, our fellow Samantha, Sunny, and Danny, as I bothered them a lot for brainstorming, user testing, and feedback. And thanks all for listening.